So yeah, as introduced, I'm Branimir. I'm one of the founders and CTO behind the project of OriginTrail and NeuroWeb, which are basically two married projects. You probably know about NeuroWeb by now as a Polkadot parachain or rollup, whatever we want to call it. And today I'll talk about something called collective neuro-symbolic AI. And I'd like to start with this picture. I'm sure all of you have seen this Pope before. So it's kind of a nice, cute sort of deep fake, which doesn't really sort of look that bad when you look at it first, but it's actually extremely high fidelity, and it shows how easy today it is to create content that looks very convincing. And actually it's so convincing that there's research recently that it turns out that AI-generated tweets are only 3%, but 3% more convincing than human tweets right now. And if the tendency is to be, that this grows, then obviously we're going to get into a lot of trouble and basically pollute the internet with very, very questionable information. So today I'm also going to talk about how we can trust the source of information. And one of the folks who is labeled as the leading AI critic, his name is Gary Marcus, says LLMs are brilliantly stupid, and we agree with him. They also, that LLMs have been around for a while. I'm sure you all have seen them hallucinate, do all of the kind of magical things, but also at the same time very tricky things. For example, if you ask something simple like, who's the Prime Minister of Denmark, ChatGPT might totally answer something random and weird, and would you consider that intelligent? It's kind of questionable. At the same time, you can ask it to write you a poem in kind of style of Shakespeare, and it will do that really well. So they're very creative. Actually, these hallucinations, they're a feature. They're not a bug. That's not just the only problem that they're polluting internet with hallucinations and convincing problematic content, which naturally comes from centralized sources, which is something obviously we don't like here, but not just that, that introduces a lot of bias. Everybody is also out for our data. So you've probably seen Claude being able to run on your machine and basically control your computer. You've probably also seen Microsoft before deploy a solution where basically they screenshot your screen and kind of do something with it. I don't know about you, but to me this sounds scary. And I think that it's totally against the Web3 ethos, and that's why we need to tackle these problems. So ultimately this is a problem of privacy as well and data ownership, which is totally being violated by the current AI giants. So, but it's not all bad with LLMs. So we can sort of take the path of AI, which is a little bit more like the actual intelligence we know for quite some time, which is our brains. So when you think of the brain, you kind of have this left-right sort of paradigm where the right brain is creative and the left brain is really more sort of mathematical, factual, And so basically this creative side is the generative side which comes up with new ideas, statistical predictions, natural interactions, while the fact side, really, that side of the brain is more about how you represent knowledge, how you can do logical reasoning, based on rules of logic or math, and basically also do rule-based inference from that. So actually, this is a new path towards expanding the development of AI in the right direction, which is called neuro-symbolic AI. It combines neural networks with actually an older branch of AI called symbolic AI. So what we're aiming towards, what the mission behind NeuroWeb and OriginTrail is really collective neuro-symbolic AI. So on one hand, we have NeuroWeb, which represents the chain for this artificial intelligence creativity, where you can plug in multimodal different types of neural AI, but also implement human in the loop. So basically collective governance, where we can also all be there and make decisions on how this thing goes further, including incentives, of course, which are a really big part of it, and I'll talk about it in a minute. Ultimately having this verifiable root for every piece of data or fact that is sitting on the other side, which in the OriginTrail world is the DKG, the Decentralized Knowledge Graph. Actually, knowledge graphs are the best technology that represents symbolic AI. That has been a branch that's been here for a while, and actually also captured by big business, such as Google invented it, for example, 2012. but everybody uses it. Netflix, Uber, you name it, and they all basically take all of the data that they can get from us, like what we watch on Netflix, where you ride with Uber, and they make knowledge graphs out of it and do knowledge-based inferencing. They were doing this way before LLMs. So knowledge graphs are really about facts, about symbolic AI engines, and what it allows with the DKG, what you can embed with it, which comes basically naturally as soon as you start using the DKG, you get knowledge provenance. So that means you know exactly where a certain statement, or as we call it, assertion, comes from, and you basically own these statements. Actually, those are knowledge assets in the DKG, so these knowledge assets, you can consider them as kind of like knowledge NFTs. Instead of like a picture NFT, you actually have a packaged bundle of knowledge, which is knowledge graph triples, vector embeddings, and you name it. You can even put other types of content in there. So wrap it up in an NFT that sits on chain. So you can look at this from kind of another perspective. We take a layered infrastructure in a kind of very abstracted way. At the bottom, we have the trust layer, which basically combines multiple blockchains, obviously NeuroWeb being the central blockchain for this. And this is really driving this auditability at scale. So we have the ability that for every knowledge asset that sits on layer 2, which is this knowledge-based layer, the DKG, we have verifiable source of information. So basically an address, an account that published certain knowledge assets, and you can see the entire provenance. If it was updated, if it was transferred to somebody, kind of like your Git history of this knowledge. And then finally, when you combine those two, on top of that, you can build verifiable AI. So plug in models, plug in agents, all kinds of different things, and you can build actually very highly precise AI that will not just hallucinate random things, but it will actually use the knowledge from the knowledge base and the information provenance from the trust layer, so that every answer, for example, of a chatbot or really any action can be guided directly from that knowledge base. So it doesn't hallucinate and think of an answer, but rather it only extracts what it can find there or reasons based on the knowledge graph. So how do we build a collective version of this? How do we build this neuro-symbolic AI? What are the 3 building blocks that we have introduced? Number 1 is knowledge pairnets. That's kind of like an equivalent of a pair chain, but in the knowledge graph sense. So for example, anyone here, any team can create a knowledge graph, a knowledge pairnet on the DKG, and can immediately benefit from this entire stack. I'll say a little bit more in the next slide. DKG edge nodes, which is something we just recently launched, which is basically your substrate equivalent in the DKG world. So you can take different palettes and combine them and build something of your own. And then finally, the collective programmatic treasury, which is basically there to incentivize builders who are building these systems on top of the DKG and the DKG itself. So building block number 1, pairnets. What are these? These are basically knowledge graphs, collections of knowledge assets. Each of these little hexagons here is one knowledge NFT, one knowledge asset. And they're usually topical knowledge graphs. So basically, they can connect different knowledge graphs with different agents, and usually they're on a certain topic. Then, of course, built by pairnet teams, like I said, you can use edge nodes actually as the other building block, which I'll show in a moment, to build your pairnet, but also include anything that you would like to use from the Polkadot ecosystem. So Substrate, Polkadot SDK, it's all there. And plug in your ontology. And ontology is really kind of a very, very rich schema for knowledge graphs. It's actually more than a schema because it has embedded logic inside, so you can even reason with it. And finally, human-in-the-loop incentives. So the on-chain governance on NeuroWeb is basically responsible for guiding this development of this technically cybernetic system, right? Providing this feedback loop where humans are actually in control and decide where the incentives go, rather than the incentives take up all of our data. And what is really good about these knowledge assets, they can also be private. So, for example, you can run an edge node on your device. Oh no, why is it dead? You can run an edge node on your device and hold these knowledge assets on your phone, so nobody has access to them. Let me try and connect to myself just quickly.
You want to start?
I think it's going to be okay. I just need a little bit of juice. So I'll show you an example of a pairnet built by, it's called SciGraph. It's a team that is building a DeSci-focused pairnet, and this should work now. Let's see. I don't know if sound is out, but it's not really that important. So this is a UI, this is the edge node actually that they customize to their UI, uploading a paper, on a science paper, creating a knowledge graph out of it, and then publishing it basically on NeuroWeb and creating a knowledge asset out of it, where, for example, you can chat with that. You can ask, for example, how many papers are in this particular pairnet, and all of the answers are going to come only from this knowledge bank. It won't hallucinate anything else. So it's effectively applying retrieval augmented generation, but in a decentralized way. You can also explore this graph, but the key thing is anybody can contribute. So anybody can come, publish papers, and actually get neuro tokens as a reward. So you're incentivized to share knowledge in their pairnet. The way they got Neuro to do this was actually through NeuroWeb governance. So for example, any one of you can launch a pairnet today, take these tools, and ask the Neuro community to basically assign an allotment of Neuro tokens for you to reward knowledge contributors. But of course, if it doesn't make sense, it won't pass governance. So essentially, the Neuro community and the Neuro token is here to incentivize the growth of this collective knowledge base, both in the public sense, so we want a lot of public knowledge so we can all use it together, but also is not limited fully to that. That knowledge can also contain private elements. Like, for example, I wouldn't, let's say, submit personally identifiable information there, but I can keep some of that as knowledge assets on my phone and then use it together with the parent. For example, maybe you've heard of this. This is called an Aura Ring. It's basically a sleep tracker. So you can find a demo online where we uploaded this to the edge node locally on my laptop, and I asked questions about my sleep habits. And it was answering only from this public knowledge in the parent, the public knowledge graph, and the knowledge on my phone, with never actually leaving, my information actually never leaving my edge node. So that's building block number 2, parenets. Building block number 3, if it moves, is this DKG edge node. So this is a new thing. We're actually building version 8 of DKG as we speak, and it's set to launch in December, where this version 8 actually brings a ton of advancements. 2 main advancements are scalability, which is growing about 1,000%, and from what we have right now. And at the same time, it brings this notion of edge nodes where the ambition is to be able to run those on any device. So like phone, laptop, but also the cloud. For example, what you've seen previously is the deployment of the edge node on the cloud, because obviously it needs to be a public interface for them. So with this edge node, you can actually take it, kind of think of it as kind of substrate. They're like elements that you can take, tweak, tune, and voila, start your neuro-symbolic AI system. And essentially, what happens here, from another point of view, is at the bottom we have devices, and all of those devices contain knowledge. And essentially, these edge nodes, you can do RAG on them, retrieval augmented generation, or you can do decentralized RAG across all of them. There's something also called a core node. This is basically your validator analogy. So let's say validator, collator, they're not doing the same thing. It's a similar thing here. Core nodes in the DKG, they host the public DKG. They collect the fees. That's where you stake, just like you delegate stake, just like you do it in Polkadot. So a lot of similarities and a lot of inspiration that we took from Polkadot, I have to say. And ultimately, you can do this decentralized retrieval augmented generation across a bit. How do you do it? Sparkle queries, for example. Sparkle is a query language for knowledge graphs, but also vector embedding, similarity search, and other types of search. You build whatever you need. Ultimately, getting this verifiable neuro-symbolic AI. So the more up you go, you get more verifiability, accuracy, and context provided by this knowledge. What does this node architecture look like? Well, it's basically very similar to Substrate. We don't have palettes, we have services, but I'll just quickly run through some of them so like it's not so black boxy. Essentially, starting from all the way up, this knowledge mining API is basically an API that allows you to build knowledge mining pipelines where you can take some input data, whatever it is, CSV, on-chain data, PDF, and convert it into knowledge graph form. Makes that very easy. On the other side, you have the DRAG API, which does the other side, the querying side, right? So you can build any type of queries you would like, both knowledge graph queries and neuro queries, or you can combine them, which is actually giving the best results. There's also a UI. Basically, your UI you can take and modify. You can think of it kind of like WordPress. boom, you install it, and you can just change a bunch of things, and you have the edge node running, has an API, has a publishing service that publishes all of these knowledge assets that you produce. Obviously, knowledge graph, LLM instance, blockchain interface that connects to NeuroWeb, and a bunch of other services, including a verifiable credential-enabled authentication service. But the coolest part here is the orange part, like what you can build on top of it. So all of these come out of the box, all open source, all plugged into NeuroWeb. So the third building block is this collective programmatic treasury. Basically, what it means, and we just launched this literally yesterday, is that those who use it will build it. That's basically the principle. So there's 60 million track tokens that are programmatically deployed on NeuroWeb for builders and are going to be emitted in a very similar fashion as to Bitcoin halvings. So 30 million at first for 2 years, then half of that, 15 million next 2 years, and so on. And that means anybody who's building on the DQG, people who are creating paranets on NeuroWeb specifically, can actually get these funds. And of course, there's a governance component to it, so the community needs to essentially vote you in. Otherwise, it wouldn't have the human in the loop, and people would be, and they're definitely going to be trying and get this juicy money. But ultimately, it's designed for those who are building it, and it's going to be meritocratic based. So the more knowledge you put in the knowledge graph, the higher let's say the incentives, the emission amount that goes towards you. So it's kind of a race. Whoever gets to add more knowledge to this collective neuro-symbolic AI first, they will get this portion of this development fund. This QR code is basically the link to the RFC that we published just yesterday, so it explains it in a lot of details, including the edge nodes and the core nodes. So if you're looking to read through, I think it's 10 pages. It's a nice weekend read. And yeah, basically those are the three elements. So knowledge paranets, which are collections of knowledge assets, the programmatic treasury, and edge nodes. And edge nodes being very new, they just launched. You've seen one implementation, but we have multiple teams already building on it. One team is actually building a knowledge graph-based connection system for people at DevCon. So you can, for example, say what you're interested in. They scrape your Twitter and LinkedIn because you allowed them to, and then they find all the other people in knowledge graph based on similarity. So it's very, very simple, very interesting application. And there's many others. Storytelling paranets. There's sports paranet I'm hearing. So a bunch of them already going in. So if you're interested into building something like that, I'm also around. You can catch me. We can bounce ideas and give you a bit more context on that. And yeah, you can basically start building your neuro-symbolic AI today. 4-step process. Basically, you set up your project. You start with an edge node. That's the easiest way. You build your MVP. You launch it on the DQG mainnet, on NeuroWeb mainnet. And you can apply even for an inception program. So those builders who are creating valuable products, neuro-symbolic AI products on NeuroWeb and DQG, will be reimbursed if once they create knowledge assets on the mainnet by up to 100,000 track. So the ones who are, let's say, the early builders are also get this potential sort of liquidity, if you will, to make this knowledge project start. So you can validate it, you can iterate, and if you do this on the mainnet, it is basically qualifying you for the inception program. This other QR code is basically the link to the docs for the edge node, so you can explore it. We'd love to hear your feedback. It's also very new. And it doesn't take too long, maybe like an hour to set it all up. But after that, you basically have a fully fledged neuro-symbolic AI system on Polkadot running on whatever machine or cloud or wherever you want to set it up. Right now, it's limited to laptops, basically computers and the cloud, but we're also going towards other devices as well. And that's it. Thanks, everybody. I hope it was interesting.
Thank you. What's that? Yeah. Good stuff. Thank you, Branimir. Hey, does
you.
anybody have any quick questions? Oh, yeah. Hey.
I love this system. It's amazing.
Yeah, it's fun.
So you mentioned something about sourcing the knowledge from users themselves.
Mm-hmm.
I'm just curious, how do you ensure that the knowledge is actually correct to begin with? Like, yeah.
It's a very good question. The protocol itself doesn't. So there's really no system in the world that you can sort of plug in something and the output is going to tell you it's true or not. But if you build in for a specific domain on your ParaNet systems that work for you, then, for example, you might want to ingest some on-chain data. You can always go and verify on-chain that it's valid, right? So you can have a service on the ParaNet that does that. Or, for example, you can have some sort of logical reasoning implemented. For example, the DeSci ParaNet, what they do is they check every time that the knowledge graph is produced if actually certain proteins that they mention are connected in the protein ontology that was built by medical researchers. So there's already a lot of knowledge that can be used, and you can use those building blocks to sort of verify the input before it actually comes in. But at the protocol level itself, it's not it's too wide of a problem. So it has to be more particularized, if you will, into certain ParaNets. So it's up to the builder to enable a system that protects the knowledge to be somehow curated. You could also do some sort of wisdom of the crowds system where you could sort of vote on what should be in the graph or not, which is great because we have the chain, and the chain allows you to do that in a very nice manner. You can use tokens for weights, staking, things like that. So yeah, it's about you building it.
So just to make sure I understand it correctly, it's basically up to the ParaNet to decide how to implement this specific service.
Exactly, yes.
Super question. Anybody else? Yeah.
So users can put source, right, in per ParaNet. So you have like similar to Substrate, similar to parachains, but do you have like similar to XCM where you can also access the source from other ParaNets?
Yes, so all the ParaNets sit in one DKG. So think of it as kind of like one big knowledge graph, one database that has multiple tables, let's say, and you can query multiple tables at the same time. Technically, better analogy is you have one database system and it has multiple databases inside, and each database is a ParaNet, and you can query it. And actually, what's really cool about this is we didn't invent some new language or something to make it more complicated. There's like existing ecosystem W3C standardized language, basically, and tools that you can use. So you can just say, query ParaNet 1, query ParaNet 2, combine the results, tell me what I find, and show me the sources. And it works. Well, we didn't build this part. We just plug in knowledge graphs inside. So you can actually pick whichever graph database you want to use, as long as it follows these W3C standards.
Thank you.
Nice. Anybody
One
else?
more question over there, I think. Yeah.
Yeah, back to Rob. Big throw.
Good job.
Nice.
Nice.
Yeah, could you elaborate a little bit on like expected scale, as well as like where you're going to go with that?
I was hoping for this question. This is really good. Yeah, so when it comes to scale, like I said, each knowledge asset is an NFT minted on NeuroWeb or any of the other chains connected. And NeuroWeb has shown the most scale, obviously, out of all the other ones. And I think we'll kind of know here why Polkadot is so great. And also, actually, applied as async backing got like 6+ something X boost. And it really was needed. We were really struggling because there's actually a lot of enterprises already using. I didn't get a chance to mention that, but enterprises like Swiss Railways, Walmart, Target, Home Depot, British Standard Institution, they've been using OriginTrail for years. And their usage is growing. There's other things in the pipeline, so we really need to scale. So what I expect to happen is that async backing will only take us so far. We will likely have to go for more cores. And it looks like it's not that far in the future. So that's one part of scalability. The other part is the V8 improvements. So the V8 improvements on the DKG network, as we learned throughout all of the versions, come out with two major new features, which are batch minting of knowledge assets, so the ability to create multiple knowledge assets in one transaction. So that's going to bring also a lot of scale. And there's something we call a random sampling proof system, which is kind of like an equivalent to, let's say, a roll-up proof that the rollup submits to the chain, like a similar type of proof for knowledge is going to be implemented that makes it much less, let's say, complex computationally for the nodes, so that essentially they get more room to breathe and they can do more operations. But yeah, we expect 1000x in terms of what DKG V8 can bring. And then as the adoption grows, the system is designed in such a way that if there's more need on the DKG level, more nodes should be spawned. And because it's not a consensus-based system, that's the great part. Consensus is at the trust layer, and that's where the consensus constraints come into play. But on the knowledge layer, it's actually more of a peer-to-peer network. So you have a different type of scalability considerations, and we can scale with more nodes, we get more resources. So both of these layers need to be scaled up, basically, and that's why Polkadot is so great in this whatever that sound was, in this manner where we can just, whenever we need it, we can just get a new core, and we're safe for the time being. So I hope that answers your question.
Awesome. Super great. Branimir, thank you very much for sharing this.
Thanks, guys. Hope it was interesting.